Today's talk is a new theory of human origins by our own member, James Hunt. Humanist Community member, he's speaking on the recent chromosome fusion theory and presents his book 23, How Humanity Came to Be. Over many years in many books, there are many suggestions that Africa launched anatomically modern humans, replacing all older species. Anthropologists say something happened, but there are very few suggestions on what exactly that macro-evolutionary event was. What evidence is there for macro-evolution in human DNA? Why did anatomically modern humans all come out of Africa? Ernst Mayr wrote that chromosomal fusions have no effect on species, but there is clear evidence that 23 chromosome humans are dramatically less diverse than earlier 24 chromosome species. Is it time to consider the obvious? Homo erectus was a 24, and we're at 23, and here's James Hunt to speak more about the whole thing. Let's welcome him. Thank you, Jim.
Thank you. Walking past the speaker squeaks. All right. Put this up on the desk here, so where it will. All right. Good morning. So, thank you for coming. I should thank the group also, because, believe it or not, my membership in this humanist community began as a result of my interest in biology. I was carousing about Stanford biology buildings, and there's often small flyers put up announcing talks that students are giving. There was, thesis defense and explanations of that sort. So the talk that I spotted was Drosophila nasal proteins as reported in the New York Times. And I thought, I didn't realize the New York Times was interested in Drosophila. It turns out that this group of grad students had been investigating Drosophila gene failure and had discovered that there was a nasal protein that, if you have the right mutation, does not allow a male fly to tell the difference between a male fly and a female fly. Normally, a male fly follows female fly around as long as he has to. It turns out that when he can't tell a male fly from a female fly, you get these little circles of 6 male flies going around and around and around. Which, amusing, but the New York Times took that and ran with the gay gene. I disagreed with that viewpoint, but the student who had been the victim of this was practicing her thesis defense on a Sunday in the Union building, in the old Union at Stanford. I said, I have to see what this is about. And I walked in and found this group 10, 12, 15 years ago doing what this group does and did and has been doing ever since. And I decided that I would be part of it. So, this is... So this is going to keep blipping off on me. I'm starting with this quote here, and I'm going to step over here. Well, I'll squeak if I walk past the speaker. Hold up the book for me, the big tome behind you, Carl. No, on the desk behind Carl, the monster. That's Stephen Jay Gould's The Structure of Evolutionary Theory. And it is one of it's bigger than, the Bibles of evolutionary theory. And here's the quote I love. And Arthur gave you my flyer, but let me walk through it once. The change from Homo erectus to Homo sapiens did not occur in a gradual and global flux throughout the range of Homo erectus, but as an event of speciation. Geologically rapid, underpunctuated equilibrium, and local in geography, probably in Africa. He's arguing that this event of speciation, when we look at the data, it's going to be averaged out over whatever period we decide to consider it. And yet he declares it to be a point event. And he also gives a date down here that this particular event of speciation, again, occurred very recently, 100,000 to 250,000 years ago, by most current estimates. So Stephen Jay Gould saw something in our history that didn't track with slow microevolutionary events. The next significant paper I want to refer to, no, that's not it. That's not it. Is that not it? No, where is it? That's not it. It's my errata. I got to have the errata page. Dashboards. All right. Here we go. This is all the chromosomes in 4 different species. These are human, chimpanzee, orangutan, or gorilla, and orangutan. And if you look down between number 12 and 13, they go from long to short. And that's because the 2 that would fit in this gap are these 2 here. So when you stylize this, it's a little more palatable, and they've organized it this way. But here we see the orangutan 12th longest and 13th longest, the gorilla 12th and 13, and the chimp 12 and 13, and the human number 2 chromosome. You can see there is this little indentation here is the centromere, and it carries across, whereas this centromere here is gone. And those are probably the 2 significant events that I will track as my key point in on this data. So this paper that you're looking at here is 1982, Yunus and Prakash, wherein they state that very clearly we came out of the great apes by this method. Or this method happened somewhere. Scientists, as you know, are extremely reticent to say what's obvious. So it took another 9 years until 1991 until they actually said the origin of human chromosome 2 because of telomere fusion. So the telomeric fusion, let me go back to this paper. The telomeric fusion is somewhere in this vicinity here where 2 chromosomes got stuck together. So after they found the telomeric fusion, they actually went on to the effort and type ran it. Now this is kind of thick to drop on people that aren't geneticists, but a telomere is the tip of a chromosome, and where did my mouse go? There it is. This region up here is called a pre-telomere. These groups here, which there are 50 of, TTA, GGG, and some damaged forms of it, up until this point right here, in this line right here, where it turns to 104 repeats going the other direction. And then we get to another pre-telomeric region. So what we have here is 50 pieces of a telomere from 200,000 years ago and 100 pieces of a telomere from 200,000 years ago, and a couple 100,000 years of noise added on top. And that's what all these mistakes are. You can look through here and see some are extra long, some have the extra G's. That's a common DNA problem. Turns out that as DNA fails over time, when it's not being conserved, there are specific patterns that it fails in. So these are recognizable. So I keyed on that evidence, and I went on to the next target, which is that failed centromere I mentioned. So what's an alphoid domain? Sorry, I don't know either. But an alphoid domain is part of a centromere. Now remember, there were 2 centromeres at the moment of fusion, and one of them is still a centromere, and of course it gets detected by this alphoid domain probe. The other alphoid domain connection on the number 2 chromosome is down where the old centromere was. So this suggests, their abstract is quite delightful. They say the ancestral centromere, or at least its alphoid sequences, have been conserved. So here we have an old chromosome with some historical regions that we can map. And that's, surprisingly, I kind of realized that when I first heard about this. This paper here is 1992. Once I had accepted the fusion in the mid-90s, I realized that we had the potential to carry this forward, that we could date the fusion itself. So at this point I sat back and said, science will get there. Science will do the fusion. There will be a book about the fusion. And it didn't happen. The book did not show up. Nothing arrived. So I started scribbling down a book and thinking of what I would have to tell people and what I would have to learn in order to say that I could tell people. To look right here. So the first thing I thought was, how did this happen? And the event of a fusion is a random event. And if you study the ancient scientists in the field, two chromosomes with genes and switches and controls get stuck together into one chromosome, but all the DNA is still there. So nothing changes. And Ernst Mayr understood this and wrote that chromosomal fusions won't change species, that they're insignificant. And yet I stand here with 46 chromosomes in a world that for 15 million years was populated by 48 chromosome species, and I think maybe it mattered. So instead of trying to become an anthropologist and learn all the species and all the tracks and all the histories of how humanity came to be, I did what a crackpot outsider scientist will do, amateur, and I said, all the 24s were all the 24s. They populated the planet, and at one point, their populating of the planet divided into two species. Well, one of those species was the orangutan group, and the other kept on as hominid. And 5 million years later, the gorilla species stepped aside and isolated away from the hominid line. And most scientists now say that between 4, 5, or 6 million years ago, the chimpanzee species diverged from what is now the hominid line. And at that point, it gets a little bit vague, because while orangutan is 24, and gorilla is 24, and chimpanzee is 24, we don't have any data to suggest whether Homo habilis was 24. So the earliest possible date for the fusion would be 5 million years ago when we split with chimp. The latest possible date for the fusion would be when humanity spread out. If both sides of that spread were 23, then the fusion was before the spread. And it's usually argued that we boiled out of Africa 100,000 years ago, so that's the low limit for me. But there's still a 5 million year range where we can place the fusion event. So then I started thinking about, species isolation. If the fusion event was 5 million years ago, then we didn't mix with them for a long time, because there's no Homo sapiens fossils until a couple 100,000 years ago. But I can't rule it out. So I began to examine species isolation. As species become isolated through various causes, they will accumulate locally selected for advantages and possibly random genetic drift advantages or disadvantages. So the difference between Homo sapiens and all the other species is what the anthropologists have been studying. And I started asking how we can set a fusion event in time. This is popping off on me here. The realization that in a world of whatever species that had a 12th longest chromosome population. You know, if there was 10,000 of these creatures, they had 20,000 12th longest chromosomes, because everyone has two. They had 20,000 in 10,000 whatever, they had 20,000 13th longest chromosomes. And after they fused together, two of them were selected. This particular 12th or this particular 13 are now the choice. They are the only. They are the stuck together pair. And I realized that this means that the diversity within the viewpoint of those. Now, it's not fair to say that the 24 chromosome people, their diversity didn't change when the fusion happened. Their diversity increased because there was a new type of them. But the diversity amongst them as a group was high, and the diversity amongst the fused pair was low. So this was the key point where I said we can use a diversity argument to suggest that the high diversity of the Denisovan fossils, and my classic for the Denisovan fossils is the statement from Svante Pääbo about the bones in the Denisovan cave. Had we not found those four skulls in the same cave, we would have thought they were four different species. That's high diversity. The human family has low diversity, despite our concentration on visible differences. Genetically, under the hood, we're very much alike. They say that there is more diversity between two gorillas living 100 miles apart in Africa than the breadth of the human family. So there I had a diversity argument, but diversity is kind of a wishy-washy mathematical statistical concept. So I really didn't have anything there. So to continue with species isolation, I suggested that Homo sapiens fused. And what did they look like after they fused? So what is a low diversity subfamily of a high diversity tribe? 7% of their DNA was stuck together and the only copy you could get if you were one of those people. Around you, they had singletons, 12s and 13s. And of course, there were hybrids that had one of the fused pair and a loose 12 and a loose 13. So my suggestion is that the drastically reduced diversity made those individuals that carried both copies drastically similar to each other. And I came up with the title, The Clone Family. They had 7% of their DNA duplicated across the family. This is more than just family resemblance. This is significant. These are the clone people. To that I added human xenophobia and suggest that tribe 24 pushed out family 23, where they had to live in isolation, breed into Homo sapiens, and then expand to take over the world. This was a good idea. This was a way to say that we separated early and stayed apart, and that's why we're a different species. And then the first grenade landed. The picture is artful, but the paper was clear. There was a jawbone found clear back in 1957 and 55, something like that, in a Neanderthal cave in northern Italy. And this jawbone looked quite human. It had a chin. And one of the distinguishing features of Neanderthal is there is no chin. So here's a jawbone with a chin. And fast forward to 2013, to when we have DNA testing. They drilled out some of this bone, they tested it, and they found that the mitochondrion, the female line, was clearly Neanderthal. This was a Neanderthal bone, or at least from a Neanderthal mother, that had human morphology. Hence the title. Now, my theory at the time was that humans bred with humans and Neanderthal bred with Neanderthal, and they could not breed because they'd been apart too long, and that little jawbone was a bit damaging to my theory. So grenade lands, theories all torn up, shredded, took a while to recover. That only happened in 2013. So for 10 years I'd been thinking I understood things, but grenades don't come one at a time. Then I dealt with the second grenade. Before I get to this one, I'll explain the mitochondrial Eve and Y chromosome Adam dates. Mitochondrial Eve is the mathematical mother of all humanity posited back in the past based on the variation in mitochondria observed in human. Every time we look at a mitochondrion, it falls into one of the haplogroups that we've named, and they all go back and they give a date of 230 to 250,000 years ago. There's another chromosome similar to mitochondrial, which is passed mother to daughter through the generations, is the Y chromosome passed father to son through the generations. It took a little bit longer, it's a little harder to work with, but by the mid-90s we had an idea of the date of Y chromosome Adam. And they kept publishing dates of 120, 140, 90,000 I saw. There's even a book that says 60,000. So here we have the mother of humanity at 250,000 years and the father of humanity at 100,000 years. I didn't like that. It didn't make sense to me. So I came up with a hand-wavy, crackpot, amateur scientist way to explain that, which was that when the fusion happened, it was spread by males into the local female population, and even by one male, so that we have one Y chromosome being scattered across a number of females, producing the next generation carrying the fusion. The realization that the fusion carries the advantage into humanity means that those are the ones that matter, because they're the founding population of the third generation. So in that population we had a variety of mothers who had different mitochondria and had amongst themselves, that group of mothers, a mitochondrial Eve in the past. And yet the Y chromosome that I was positing for this is the Y chromosome Adam from the first male, or the first few males, first few generations, who capture into the local population this second generation of 47. They're not 23, they're not 24, they're 47. The 47 generation, as I say in the book, are friendly to each other. They look alike. They are the children of their father. They're from different mothers. So I'm going to suggest that maybe not in the first generation, but there are today 7 billion descendants of that generation that have the fusion. 7 billion didn't start from nowhere. So somewhere these 47s had a child that got the fused chromosome from mother and the fused chromosome from father. And that person, or male or female, we don't know, that person was the first truly human 46 chromosome creature. So that was where I said the difference between the Adam date and the Eve date argues for my theory. Incoming. Where am I? So, this was discovered in America, but it was quickly traced to its source. I mentioned that every Y chromosome on Earth falls into the every mitochondrion on Earth falls into the mitochondrial tree that we have so far looked at. And up until 2013, every Y chromosome on Earth had fallen into the tree we knew how to look at. then a bombshell comes in. And it shook up the whole scientific community because a Y chromosome was found that was not a little bit different, not slightly outside male 0. This Y chromosome was given a date of 338,000 years back to a common ancestor. This is a little special. They called it the A00Y chromosome. It was found, as I said, in America by someone doing a genetic survey of themselves, and was traced to a valley in Cameroon, the Kribi Reserve, where a percentage of the population all carry the A00Y chromosome. So now I have a theory with all these grenade holes in it, and I have to figure out a way to patch this. So the patching of a theory is a delicate thing. You're grasping at straws or finding new data or something like that. And all I really have to tell is a story. But it's a story that fits with what I know about humans. I propose that after the fusion, there was a population expansion by the 23s and the 47s as they expanded out from their original source. Data for that being that we have expanded out to 7 billion now. As we expanded, some of them must have entered the Kribi Reserve of Cameroon. And if those that arrived were female, and the local Homo erectus were normal 48 chromosome Homo erectus, carrying the A00Y chromosome, and succeeded in producing children with the arriving 47s or 23s, now we have a generation of 47s carrying this new Y chromosome that has introgressed into the human family. So, is it a strong argument? I don't think so. Is it a potential explanation? I'm willing to go with it. So, what's my next one here? So sometimes you don't get grenades. Sometimes you get fireworks. The reason that this book came out in 2015 is that I had promised myself I would publish. I was pushing the book together and taking it slow. And then one day the fireworks went off. I read a report after Burning Man this year of a gentleman in China whose parents were cousins. They had known each other. They were part of the same extended family. Not close cousins, but close cousins. And this gentleman's DNA was tested after his child had a genetic problem and passed away of cystic fibrosis. It was discovered that this person had 44 chromosomes because, as you can see right here, both of his 14th longest chromosomes are stuck to both of his 15th longest chromosomes. He's alive today in Wuhan, China. So the Chinese verified this case, and I think they argued that this is telomeric, though at this point, so recently after it occurred, he suffers from dicentrism. Now, dicentrism means 2 centromeres, and if every chromosome must have 1 centromere, when you stick 2 together, you have 1 chromosome with 2 centromeres. And Ernst Mayr, again, was one of the first that worked on this, along with Barbara McCartland, who suggested that this is a problem for fertility. This is cell divisions by meiosis, which is the sexual reproduction, will have problems at meiosis due to dicentrism. So this person has dicentrism, but obviously we got through that. We came through the other side. No one is dicentric now. The old centromere has failed, as I say. So this was clear fireworks. I thought this should have made the evening news worldwide. It didn't. All right, so I'm going to explain the weaknesses of my theory. And not all scientists do that, but because it's a popular book, I have to put out what the problems are. So all through this talk so far, I've been referring to the fused chromosome as a single unit. This is number 12, number 13. They're now called number 2 because it's the second longest. And yet there's a problem. Chromosomes don't stay unique. Every time you pass through meiosis, this event here can occur. And it's a lovely little picture that was drawn 100 years ago by the scientist who led the fruit fly laboratory at Columbia. The crossover event occurs only during meiosis. So this shows the parental female or male, I don't know which is which, but the parental chromosomes, one from each parent, sort of get tangled during meiosis, and what ends up in the next generation is this pattern. That's crossover. So if this fused chromosome gets crossed over and blended and mixed every time it goes through meiosis, the fact that it's always the same is not true anymore. So that's a real weakness in my theory, is the rate at which crossover occurs. So we're going to have to figure out what the rate of crossover occurs. How often do segment swaps occur when you do this? And the only data we have would be our own history of our own genes across the human race, except for one family in China. We now have a family that has a fusion. We can now measure how much crossover has occurred in those people as they produce this gentleman who's alive today. We will know how much crossover occurs on each generation by studying the changes in his fused 14 and 15. I don't know what the sum of 14 and 15 is for length. Third or fourth longest? It's a question I have to ask my friends in China. Luckily, I'm actually in contact with the lead author of the 44 chromosome man paper. So expect new information there. So then I started asking about, what have other scientists come up with for a date for the fusion? Here's a paper, also 2007, which I had not seen, where they used a biased clustered substitution. Now, clustered substitutions occur over long time periods in species. It appears to be genetic decay of some form. And the rates, the locations also appear to be slightly tied to telomeric or other things. They give a picture down in the paper here of the entire genome. Oh, I don't think I have the whole paper here upright. Where they actually look at the unexpected biased clustered substitutions, UBCS, and they have a graph which shows a peak at the fusion point. So that kind of marks the fusion point that there's something there. But they use the pattern of unexpected biased clustered substitutions to suggest a date for the fusion. And I don't know if it's in the abstract or not. As recently as 740,000 years ago and no more than 3 million years ago. So this is good. This is putting a bound on the date. So dating that boundary is important. And yet, around this time, I've got my own date, because I suggest that the diversity step between Homo erectus and all the other species and the low diversity Homo sapiens marks the fusion. But that would be before about 200,000 years ago. How much before? Could be argued. Not 500,000 years before. So this is different from what I've been proposing. It says an earlier date. And then just this week, I was speaking, oh, it's not in here, it's down one of these, isn't it? Let me close some of these. What was that? That's messages from my mother. Here's the other, the latest grenade. And I literally saw this paper 4 days ago. It does not appear in the book. This is the data that was extracted from the fingertip of a single Denisovan child, a girl fingertip found in a cave in the Denisova region. I believe it's the southern Caucasus. It looks like, if you know how to read these strips, it looks like this is a fusion. And yet I argued that if the fusion was recent, 250, maybe 200,000 years ago, it could not have been original to Denisovans, because they separated from the mankind line, or from the human line, when Neanderthal separated. That the first out of Africa wave that took Homo erectus worldwide, if that had the fusion, then my date is wrong. My analysis of what the fusion does and what it does to diversity is also wrong, because there is no earlier diversity step to point to. So this grenade here only has, and this definitely falls into the crackpot grasping at straws field. This bone was dated 72,000 to 84,000 years ago. My only suggestion for how this fusion could appear in that bone that is clearly not a human. I mean, the DNA from that bone was so well readable that we know not only that Denisova existed, but that it was a completely separate species from Neanderthal genetically. There was wide variance away from Neanderthal. But again, wide variance versus the narrow variance of the human family. So the suggestion I will toss out, and I don't know how I will support this, is that the human chromosomal fusion did occur in Africa 250 to 200,000 years ago, and had reached the southern Caucasus by 84 to 72,000 years ago, and started to blend into the local population, one of which fossilized. So that's where this theory sits now, and it needs to go there. But I'm going to call us back to here about the dating of the event of speciation. I'm going to point out that I have a flaw here. I have called for, Jay Gould has called for the recognition of an event of speciation. And yet, the Denisovan data calls into question that maybe the fusion was 700,000 to 3 million years ago, and there is some other cause of the event of speciation Professor Gould remarks on. I'm not going to come up with a second theory for the birth of humanity. This is the only one I have. I'm sticking with it. All right, I've tossed a bunch of hooey. Let's see how much stuck and who has questions.
Okay, I'll keep track of who puts up their hand first, and I will bring the microphone to you. Please don't speak if you don't have the microphone.
Now, it seems that the chimpanzees are different from us because they have similar fusion.
The fusion does not appear in Pan. There is, however, one interesting genetic history. A long time ago, it was argued whether gorilla or chimpanzee was closer to human. And in recent years, it has been discovered that there is a small piece of the number 1 chromosome, the longest, that appears in the number 1 chromosome in orangutan and gorilla, but in chimpanzees both and all humans, that piece of DNA that was on the number 1 chromosome is now on the Y chromosome. So we have historical data that says we diverged from gorilla first, then there was this introgression event which became fixed. I don't know why, but there was a fixed transfer of a piece of a chromosome from the 1 into the Y that appears in all chimpanzees and all humans. So there's that, it's proving our interrelatedness. But the chromosomal fusion, chimpanzees are a 24 chromosome species, whereas all humans are 23.
Anybody else?
Oh, great presentation, Chip.
Thank you.
Thank you.
Did I fool anybody?
Yeah. Well, I don't know. I didn't realize you were focused on this, trying to date it so carefully with diversification, and you didn't specify what the form of evidence of that diversification was. But of course, if you see it in the chromosomes and the genes in the chromosomes, that's completely valid and shows diversification. But when you start looking at bones and skeletons, you got to wonder about how their diet and experience might have been different. But anyway, but what I'd like you to expound upon, I'd like to see enlarged a little, is the idea of viability of populations that have undergone chromosome fusion. You explain why or why not an individual which contains a different number of chromosomes would not survive or produce offsprings in that population. Because this is the whole nugget of why this is a sudden event and the struggle of how it would greatly change a species or make a new species. And then I have to wonder, of course, all us mammals have many of us different numbers of chromosomes. And so there's been a lot of fusion going on. So this is not a unique thing that just happened to humans. And is there evidence in those populations of how viable and how they survive when an individual first undergoes, he's the one that represents this event of a fusion, how that time when the population is mixed with some with the fusion, some not, can individuals mate with the wrong number of chromosomes and produce ones with the previous right number, and then eventually there's the event of two with the wrong one forming the species. Is this what happens? I'd like to see that picture, if you could expound on it a little more.
So I did an awful lot of research on chromosome fusions. I stuck to mammalia because there are a few species in some other major realms that are really crazy about their chromosome number. There is a species of clam where the chromosome number varies in any one you pick up. But within mammalia, I have 4 or 5 examples to discuss. The first being, there is an ancient horse called Przewalski's horse. It's almost extinct. I forget the exact numbers. I think Przewalski's horse has 58 and a domestic horse is 56. 2 chromosomes got stuck together to produce the 5th longest chromosome in a domestic horse. That is an example of a fusion that we've come through, that the species came through and survived out. Another fusion that I am aware of that was studied in the United States was a herd of sheep identified in Colorado. And I've lost touch with the paper. I remember reading the original paper, and I cannot find it online, that were discovered to have a chromosomal fusion. And the key point was, I don't know if it was fixed or common or rare within this herd of sheep. But the sheep were not negatively impacted. They were not super sheep. They were just sheep. And therefore, that suggests that on the short-term time scale, a chromosomal fusion, as Ernst Mayr said, does nothing. I'm going to go to the long scale in a minute, but let me mention a couple of other species. One species that might matter to this discussion is Homo sapiens. And we have one example in Wuhan, China, of a chromosomal fusion occurring in a hominid and being passed on through two paths to reach one individual who got it from both parents. Once again, no one noticed until his child died of cystic fibrosis. And the genetic research on that child found this event. And it carried back from there. This again says chromosomal fusions don't matter, so why do they fix? Once again, I will refer to Homo sapiens. I don't know why they fixed, but they sure did. We are 23. As to the argument for how the fusion can bring people together or apart, this is where we get to truly the most crackpot idea that I have. That those with the fusion were the clone people and were socially isolated because they all looked alike. And you let that go for a few generations, now we've got an argument that that may have been the speciation cause, was the social isolation of the clone people from within the highly diverse tribe 24 they found themselves within. It's important to realize that if this is also the cause of the population bottleneck that we see in our history, this could explain the isolation necessary for the fused individuals with low diversity and low genetic input to suffer founder effect from isolation. So genetic isolation is a key to what it is that's separated from, as I say, the fusion individual started with Homo erectus separate. It's still Homo erectus. But today we're Homo sapiens. So there's a weak, but I don't know if it's sticking or not. Let's just go with it. Jonathan. Oh, back here.
Thanks for your talk. Could you give a layman's explanation, definition of what do we mean when we say simply people, us? What does that mean? Is that Homo erectus, Homo sapiens, or whatever? That's one thing. And could you comment a little bit about the idea of the Java and the Peking man, which the very popular theory for quite a long time was that the cradle was out of Asia. Thank you.
This goes back to the propensity of anthropologists to all want to be splitters, because if they can name a new species, it's their species. So what you find is that every new bone is a new species until proven otherwise. So the other components of the family that we came out of, they've been named by various professors over the years, and for a long time Homo neanderthalis was Homo sapiens subspecies neanderthalis, and Homo sapiens subspecies sapiens was us. But as far as I know, every human on Earth is a 23, and so Homo sapiens appears to be 23. I can't say if Neanderthal was a 24 or a 23. I don't have any way of knowing that without the DNA data. My only argument for it is the step in diversity following, or more likely from Homo erectus in Africa. So the separation is vague. The definition, I can't say that Homo erectus was a 24. I don't have the proof. So this is crackpot science here. extended? Oh, up there. Jonathan.
I can answer your question about Java Man and Peking Man.
Yes.
Java Man was discovered in the 1896 at a time when, Darwin's Origin of Species was published in 1859. It wasn't that long after that became reasonably predominant as the current theory in science for the origin of species. And Peking Man was discovered in the 30s in China. Both of them are subsumed in the Asian Erectus binomen. And as far as why the cradle of Homo sapiens is Africa, sub-Saharan Africa rather than Asia, is based on about 8 or 9 independent lines of evidence. The first was a person ahead of me in grad school at Berkeley, Becky Kahn, who is responsible for the Mitochondrial Eve hypothesis, because when she looked at the mitochondrial DNA in all modern humans and calculated the rate at which the mitochondrial DNA undergoes substitution events, that gave the time depth of about 180 to about 280,000 years ago. But that is consistent with, actually the first out of Africa hypothesis didn't stem from her mitochondrial DNA data, it stemmed from the archaeology. The earliest example of the kind of tools we have associated with anatomic modern humans we find in sub-Saharan Africa. The earliest fossil evidence we have of anatomical modern humans dates to 160,000 years ago in a site in Ethiopia. The linguistic data supports an out of Africa model because there is more linguistic difference between African languages than between languages across the rest of the world. Right? So we have linguistic data, archaeological data, paleoanthropological fossil data, and mitochondrial DNA data that all have the same answer, that all modern humans can trace their ancestry to a population living in sub-Saharan Africa, somewhere in the 180, 280,000 year range. I was just going to say that one of your ostensible problems with your hypothesis is not a problem at all, because when you're talking about crossing over events, recombination, that happens between homologous chromosomes. It doesn't happen between non-homologous, and so as far as I was trained in genetics, in biological anthropology, and I don't see that as having anything to say about your hypothesis, which I find highly intriguing. I mean, I've been aware of the fusion event between the ancestral ape 12 and 13 producing the human 2 for about 25 years, and I always assumed, and it's the other alternative hypothesis to James, that this happened at the root of the human-chimp split about 5 million years ago. And I've always assumed that the regulatory genes that control the timing and development of 2 of the 3 pelvic muscles, gluteus medius and gluteus minimus, which differ markedly between humans and apes, and refashioned our pelvis to the modern human pelvis, are probably found near the centromere of our current number 2, because they probably were on the ancestral 12 and 13. And if we were able to sequence the 2 and know what their function is, that would be a way to test whether this fusion event happened 5 million years ago at the start of the human versus chimp line, or whether it happened more recently, as James is suggesting, at the start of
preceding Homo sapiens.
Yeah, and I'm a cladist, so I refer to to me, Erectus is only in Asia, and what we have in Africa is Ergaster, but they're similar morphologically. But between the Homo Ergaster giving rise to the earliest Homo sapiens in Africa, and so, I mean, I find this intriguing because James's hypothesis, in a scientific sense, is equally plausible to having the fusion event happen at the beginning of our subfamily line 5 million years ago. And then the question in science is, how do we test and distinguish between those two possible explanations? As far as your notion that social exclusion led to the isolation of the 46 diploid number humans versus the 48 ancestral population, I don't think that's also necessary to your explanation, because when you're dealing with a wide-ranging species, we know this from evolutionary biology, towards the species show a certain pattern over the landscape that they occupy, and any widespread species has populations, and populations are defined as parts of species where there's more interbreeding than within the population than between populations, right? They're naturally interbreeding populations within a species. And you have larger populations of a species near the center of the range. And as you go farther from the center of the range of a species to the periphery, you get more widely dispersed and smaller populations. And that's where these kind of punctuated genetic events happen, right? The smallest population is like an adult male and an adult female, or adult male with a couple of adult females, right? And if this chromosome fusion event happened in a population of relatively late African Homo Erectus, which fused the ancestral 12 and 13 into a longer number 2 because they're named based on their length, right? That small population that it happened in is already relatively genetically isolated from other populations of the species. And so you don't need social exclusion to get it isolated.
Just geographic exclusion.
It's basically geographical isolation. And the other thing that's maximized in, well, there's two things that are maximized in small populations. In a large population, natural selection plays a predominant role in shaping the genetic makeup. And genetic drift is reduced when you get above an effective population size of 500. 500 refers to the breeding individuals, so you're excluding people too old to mate and those too young to mate. When you get a small population, and the farther below 500 effective population size you get, genetic drift's effect increase and selections decreases. And so, given that we're talking about telomeric to telomeric fusion, and telomeric DNA is by definition non-coding DNA, it's not producing proteins, it's not a structural part of the DNA, right? This would be a selectively neutral event, and so natural selection doesn't act on selectively neutral differences. Drift does. And if this is happening in a small isolated population on the periphery species range, you could go from, within a couple of generations, from one male, which I think is more plausible given the difference in time depth between the Y DNA and the mitochondrial DNA data, one male with this fusion event giving birth to, with different females maybe, to a son and a daughter who are heterozygous for that fusion event. They have one number 2, and then they got a 12 and a 13, right? They're 47 diploid number. And the other thing that's maximized in small populations is inbreeding, right? So you get a brother-sister or first cousins, of different sex within 1 or 2 generations who produce offspring, and that's how you can go from a single individual with a fused 12, 13, creating a long number 2, to individuals that have 2 copies of the now fused, the longer number 2. And so they have a 46 number rather than a 48 diploid number. It's the genetics is understood. Fusion events happen all the time. They tend to happen in acrocentric chromosomes. Those are chromosomes where the centromere is not in the middle. It's closer to one end, right? And I think that the 2 viable hypotheses is the one that I've always believed, because until I read James' book and met him, that it happened at the origin of the human-chimp split. But his idea is equally plausible, and now we have to figure out ways to distinguish between the 2.
Thank you, Jonathan.
Well, that's a hard one to follow. My question is significantly shorter. So when you have a 23 interbreeding with a 24, and if I remember how this works, which has been a long time, that the genetics mixes up between the 2 parents, and it's a somewhat random as to which one you end up with. But when you have the fused gene matching up with 2 non-fused genes, I'm trying to imagine the physical mechanism that occurs, and if because one is longer and it would have to match up with 2, wouldn't that make it so that physically they don't match up, so 23 wins? So once you have a 23 breeding with a 24, the 23 wins because the 24 would have to match 2 genes instead of 1. Is that a possibility, or am I completely?
Well, let's run this picture here, where instead of one of these, let's put a second one beside it. And in one individual, it's a long single, and in the other, it's 2 separate. Could there still be crossover? Jonathan suggested that there would be reduced crossover, and David Kingsley at Stanford also said reduced crossover because of the fusion. So we may have a case where, having fused, they disentangle in preference to the fused pair. That's something that should be studied. And yet, the very rate of crossover in mammals, I have heard a wide variety of suggestions for what the rate of crossover is. This little crossover event shows two crossovers: crossover, crossback, and remix. So that produces, for a single chromosome, this pattern. There is a book out there I read which suggests that every single time you go through meiosis, you get 1,000 crossovers. If that is true, there is a weakness here.
Again, I'm trained in genetics.
Please don't speak when you don't have the mic.
Yeah, but even if it didn't happen every time, if there was a probability towards the 23, if it were 55-45 even, that over time the 23 would win.
And once again, I really look forward to the study of this family in Guangzhou to see what their actual crossover history was. Thank you, Jonathan.
Again, I think that the rate of crossing over, which only happens in homologous chromosomes, so you don't cross over genes from a number 1 chromosome with a number 2 chromosome, right? I mean, everybody in this room has 46 chromosomes, right? Everybody in this room, when you produce gametes, male gametes are called sperm, female gametes are called eggs, they have the haploid number, they have 23 chromosomes, right? And in meiosis, which is sexual cell division, the first thing that happens is let's say in my sperm, I get one of my number 1 chromosomes came from my mother, the other number 1 chromosome came from my father, and when I'm making sperm, both of those duplicate. So I have a duplicated version of my paternal number 1 and a duplicated version of my maternal number 1, right? That's the first step in meiosis. It's after that duplication event that crossing over happens, right? And so genes that I carried on my number 1 chromosome I got from my father can be exchanged with genes on the number 1 chromosome I got from my mother. And so it creates different packaging of genes on homologous chromosomes, which is why it is not a problem in your hypothesis, because it doesn't affect anything that James is talking about. As far as the question from over there about are there problems with the individual who, let's say, has 47, an odd number of chromosomes,
Yes.
right? A fused 12-13, which is the number 2, plus a separate number 12 and a number 13 from the other parent. We know, for example, that gibbons, lesser apes, although there's a range of chromosomes, there's species of gibbon that have a diploid number which is lower than siamangs, which is the largest kind of hylobated lesser ape. And we have hybrids between siamangs and this gibbon, which means the offspring have an odd number of chromosomes, right? And we also have known that those hybrid offspring can reproduce. So we have empirical evidence that you can have hybrids between species that differ by 2 chromosome number, and that the hybrid offspring that have an odd number of chromosomes can, in certain circumstances, be fertile and produce offspring. And that supports James' hypothesis, and it also supports the alternative one that this fusion event happened, 5 million years ago rather than 250,000 years ago. So, yeah, it's totally plausible.
Okay, we'll have that be the last comment.
I'll throw one more detail. In the book, I run through the gibbon population. The gibbon species have haploid numbers of 19, 20, 25, and 26 across 17 different species. And as you said, in zoos, hybridization has been seen to occur. I have not seen reports of fertility, though. Thank you for that.
Okay, let's give another hand to